Okay, on page 8 of your star push, I basically just did one of the boxes to give you a general idea of what you're doing here, a gist of what you're doing. The atomic number of helium is 2. How do I know the atomic number of helium is 2? Well, I look at my periodic table, I look for helium, and I see that my atomic number, we said, is always the same as your protons and electrons. So I'll circle that. My atomic number is at the top. How do I know the difference between my atomic number and atomic mass? Remember, I told you guys to think of it as a scale. And the number at the bottom of the scale, when you're standing on the scale, always gives you your weight. Well, let's think of this as a scale, and everything is on top of it. This is giving me my mass. So I can always identify the number at the bottom as my atomic mass, and the number at the top as my atomic number. So the atomic number is 2. My atomic mass is going to be the number at the bottom, like I said. And that is going to be 4.003 in this case. You can round it off to 4. The group or family, remember your group numbers are read down. So we look over here at the top. This number at the top is group 18. That means everything down this row here is group 18. Your period, down this row or family. Your period or row is read across. All right, so I read that across here. No matter if you have this big gap on your periodic table, it's still read across. The hydrogen and helium are both still, let me lift it up so you can see it. The hydrogen and helium are still in period 1. You see this 1 over here. It doesn't identify by telling you the period, but we know that we read it across. So this is period 1. Your number of protons, like I said, if we already know our atomic number, we know the number of protons and electrons. So since our atomic number is 2, that means our number of protons and electrons is also 2. Our number of neutrons. How did I tell you guys to get your neutrons? Think about ape man. Think about the man part of that. Your atomic mass minus your atomic number gives you your neutrons. Well, I have my atomic mass of 4 minus my atomic number of 2, which is going to leave me with 2. So that tells me I have 2 neutrons. What about my number of valence electrons? Your valence electrons are the electrons on the furthest ring out. Well, for this particular Bohr model here, this element, we only have 2 electrons, period. We only have 1 energy ring. So that means it is full. So that means these will be considered my valence electrons. So I have 2 valence electrons. Is this element stable, somewhat reactive, or very reactive? You can either circle the word stable or write the word stable out because it is in your noble gases row. As long as your valence electron row is full, this holds up to 2, so it's full, then it is considered to be stable. Your number of energy levels, you just count how many rings you have. 1 ring means 1 energy level. Your element with similar reactive properties, you can take any one in that group, in the same group. And these are all going to exhibit the same properties when it comes to reacting with others. Your noble gases all react the same. They're full, so they are stable, non-reactive. All right, we'll see if you can do the rest of these on this page on your own. All right, moving on to page 9. All right, we have more work with Bohr models. It asks you first for your atomic number. We look at the element that would appear on your periodic table. Your atomic number, like I said, is always going to be at the top. When we know our atomic number, what else do we know? That's right, we know our number of protons and our number of electrons. So when I write in this atomic number of 18, so I don't mess up, I can go ahead and write in for our number of protons and electrons, 18 and 18. Have that figured out. All right, the next one asks me, what is my group number? Well, I look at my periodic table, and I find argon on there. Argon is right here, so that means that it is group number 18. So I wrote that in there. What period is it in? Well, I can determine my period simply by counting the rings. If I have 3 rings, That means this is period 3. Boom. I have that. I could have also, without using the periodic table, figured out my my group number by simply counting the 8 valence electrons on the outside. Alright, the next thing I need is my atomic mass. I just simply rounded off 39.948 to 40. So that when I tried to figure out my neutrons, I used the man on 8 man and subtracted my atomic mass, my atomic number from my atomic mass, which gave me 22 neutrons. What is the charge of the nucleus? The nucleus is always going to have a positive charge. Always going to have a positive charge. In this case, it is a positive 18, since there are 18 protons. Solid, liquid, or gas? Well, all your noble gases, of course, are gases. So it's going to be a gas. Name an element with similar properties. Remember, when they're talking about similar properties, how do they react with other elements? All right. So in this case, anything in the same group would have similar properties, and that's why I chose neon. Is it a metalloid, a metal, or a non-metal? Well, since it's a noble gas, that tells us automatically that it is a non-metal. How many valence electrons do we have? We simply count out how many are on the furthest shell out. Those are your valence electrons. 1, 2, 3, 4, 5, 6, 7, and 8. Is this element very reactive, somewhat reactive, or stable? Well, if your valence electrons are full, think about you when you get full. You're not going to want to move too much. So this is stable. Name the element to the left of argon. I already looked at my periodic table. The element to the left was chlorine. 2 physical properties. It's clear and it is odorless. Name an element in the same period as argon. In the same period, well, if one of the elements is to the left or the right of it, those are all considered the same period. So I just went with chlorine again, making it easy for myself. Name an element in the same group as argon. In the same group is going to be read up and down because your groups go down the columns. All right, so anything in group 18 would suffice. In this case, I chose helium. All right, so that was doing a problem off of this page. Let's see if you students can do the other one on your own. All right, again, I hope this has been helpful. We'll go through a few more pages tomorrow.